Welcome to the crossroads of gaming and web development. Hello, I'm SwapUp Gaming. In this tutorial, we're not just coding, we're revolutionizing your game development experience by bridging your Unreal Engine games with the dynamic world of web APIs through Node.js and Express. Imagine your game alive and interacting in real time with a server, opening endless possibilities. Are you ready to transform your game into a connected powerhouse? No more delays, no more wondering, we'll make it happen right here, right now. Let's unleash the full potential of your game, and we start by understanding the backbone of a server-side operations, Node.js. Before we dive in, let's talk about what we're going to do here today. We're about to lay the groundwork for your journey into back-end development by creating a very basic API using Node.js. Along the way, we'll learn what Node.js really is and introduce you to the concept of frameworks, mainly focusing on Express.js. We'll also explore some great tools like Nodemon that will really accelerate our development process. Once we establish our API and have the server humming, we'll shift gears and leap into Unreal Engine. Here, we'll bridge the gap between game development and web technology by connecting our Unreal Engine project directly to our new API. You'll learn how to fetch information provided by the API and display it right within your game, an essential skill for dynamic, data-driven gameplay. This tutorial is so much more than coding. It's about understanding the building blocks of web and game development. As we walk through each line of code, I'll explain its purpose and functionality to ensure that you grasp the why behind the what. This foundational knowledge is crucial as it serves as the cornerstone for more advanced tutorials in the future. So if you're ready to start this exciting journey, remember to engage with the content, like, subscribe and share if you find it helpful. Let's begin this learning adventure together, step by step, and remember, we're here to understand each part of the process, moving beyond the mere copy-pasting towards genuine comprehension and skill building. Alright. Node.js is not your typical programming language or framework. It's a powerful JavaScript runtime built on Google's V8 JavaScript engine, the same engine that powers Google Chrome. Node allows you to run JavaScript on the server side. Traditionally, JavaScript was confined to the browser, shaping the user experience on the web. But with Node, we break that barrier using JavaScript's flexibility and power in a server environment. So why is this important for game developers, especially if you are starting out? Using Node, you can create highly scalable server solution for your game, manage player data, facilitate real-time multiplayer experience, and the best part is leveraging JavaScript, a language many developers are already familiar with, thanks to its dominance on the web. But how does this all tie in with Unreal Engine? That's what we're here to explore. By connecting Unreal Engine with the Node.js server, we open a realm of possibilities from multiplayer functionalities to dynamic content updates. In this tutorial, we'll go step by step, demonstrating how straightforward it is to set up a server with Node.js and Express, and then linking it to your game created in Unreal Engine using C++. We're focusing purely on the connection today, ensuring you understand the core concepts without getting bogged down by unnecessary details. In today's tutorial, as well as others going forward, we'll be using some key tools to set up and test our server connections. Understanding and installing these tools will be essential for following along with our projects. First up, we have Visual Studio Code, commonly known as VS Code. It is a free, open source code editor created by Microsoft. It's very popular among developers for its lightweight design, powerful sourcing code editing, and large plugin ecosystem. Most API programmers prefer VS Code because it simplifies code writing and debugging, and it supports a vast array of programming languages and frameworks. It's an all-in-one tool. It makes our code journey smoother and more efficient. Next, we'll be using Postman, a powerful tool for API development. Postman allows us to create, share, test, and document APIs easily. It's a great tool for developers working on server-client applications, because it simulates API requests without needing a front-end setup. This means that we can test our endpoints quickly and efficiently, making sure everything works as expected before integrating it with our Unreal Engine game. We might not use it today, But if you really want to learn about APIs, you need this in your arsenal. I might do a deep dive into how Postman works in a separate video in the future. And of course, we'll need Node.js, the backbone of our server operations. It's what allows us to run JavaScript on server side and build our API with Express. Make sure to download and install the latest stable version to follow along without any hitches. You can find all the links for downloading these tools in the description below. Make sure everything is installed before proceeding with the tutorial. Now it's time to shift gears from theory to action. Let's roll up our sleeves and dive in. After all, there's no better way to grasp these concepts than by actually applying them. Ready to transform knowledge into experience? Let's jump right in. Here we are in VS Code and an empty slate. I have opened a directory or folder that I want to place my application in. To open a directory you want, just go to File, Open Folder, and choose the correct folder. With your Node installation came something called NPM. NPM stands for Node Package Manager. It's a massive repository of open source code packages that developers can use to add new features to their projects without writing the code from scratch. NPM makes it easy to install, share, and manage dependencies, libraries, and tools in your project, ensuring you can build complex applications more efficiently and effectively. It's like a giant library where you can borrow code written by other developers, streamlining your development process. To start a new Node project, we use the terminal. To open a new terminal, if it's not open, just go up to Terminal and New Terminal. Make sure that we are in the directory we want to put our project in and type npm init and press enter. This command will start a process that creates a new Package.json file for your project. You can press enter to accept the default values or enter your own values for each prompt. However, all these values can be changed whenever you want. I will just press enter to get the default values. After running the npm init command, you notice a new file in your project directory called Package.json. This file is like the heart of your Node project. It keeps a record of various important information about your project. Firstly, it contains metadata relevant to the project, such as the project name, version, description, and the entry point file. It is typically index.js or app.js. This information helps identify the project and its main characteristics. Secondly, Package.json tracks all the project's dependencies. These are the external packages your project needs to run properly. When you install a package like Express using npm, it gets listed here under dependencies or dev dependencies, depending on the use case. This helps ensure that anyone else working on the project can install these necessary packages with a single command, npm install. So it is really easy to share a Node project between team members, because you never have to share all the dependencies. They will be automatically hooked up when they install it on their system, all thanks to this file. Furthermore, this file can include scripts, which are custom commands you define to automate tasks such as starting a server or running a test, and we will be using such a script in just a few minutes. In essence, Package.json is a blueprint for your application. It informs others and yourselves about the project and instructs npm on how to handle your project's dependencies and scripts. Think of it as a manifest or a guidebook for your Node project. Alright, now that we have a Node project up and running, let's understand a crucial element of modern web development, frameworks, with a spotlight on Express.js. In the world of programming, a framework is essentially a toolset or scaffolding that helps developers build applications more efficiently. Think of it as a blueprint or a set of pre-written code that takes care of the routine tasks, allowing you to focus on the unique aspects of your project. Frameworks can speed up development, enforce best practices, and make your code more manageable and scalable. Now, when it comes to web development with Node, one framework stands out for its simplicity, flexibility, and efficiency: Express.js. Express is a lightweight yet powerful framework designed to build web applications and APIs. It's unopinionated, meaning it doesn't lock you into a specific way of doing things, which offers the flexibility you need to adapt to different project requirements. But why Express for game developers? The answer lies in its simplicity and speed. Express streamlines the setup for your server, handling routes, requests, and middleware with ease. It's perfect for setting up APIs that your game can interact with, whether you're tracking player scores, managing game stats, or handling multiplayer interactions. Throughout our tutorials going forward, we'll utilize Express to create a robust backend for our Unreal Engine games. You'll learn how to set up endpoints, manage requests, and connect your game to a server that can handle real-time data. All of this with a goal to enhance your game's functionality and player experience. So to install Express to our project, we'll use the command we talked about before, npm install. So in our terminal, we just type npm I Express. The I is short form for install, and Express is the name of the package. There are more flags or options you can add to your package. You can find a link to an Excel sheet with most of the options in the description. When you install packages in your Node project, another file called Package-lock.json is automatically generated. This file is crucial because it keeps track of the exact versions of every package that your project depends on, as well as their dependencies, ensuring that you and anyone else working on the project uses the same version. The Package-lock.json does more than just record versions. It also helps improve the installation process by providing a clear map of which versions are installed and how they are interconnected. This ensures consistent installations across different machines and environments, eliminating the "it works on my machine" problem. While Package.json gives you a broad overview and allows for flexibility in package versions, Package-lock.json locks that down to ensure consistency and stability. You typically don't modify this file directly. It's managed by npm. However, it's important to include it in your version control to maintain consistency across all development and production environments. We will delve into version control in a future video. Alright, we have now a Node project and we have Express installed. Let's get our server up and running on our local computer. We begin by creating the initial file for our project, known as the entry point file. This is the first file that will be executed when our application starts. In our project, we specify this entry point within the package.json file. For our case, the entry point will be index.js. First of all, we want to include Express. We do this by adding this line. This line imports the Express library into the file. The require function is used by Node to load modules. By assigning Express the result of require Express, you now have access to all of Express's methods and properties in the Express variable. Next, we want to create an instance of the Express applications by calling the Express function. This app object is what we'll use to set up a server, and later we can use it to include routes, middleware, and listen for incoming requests. Now we want to set up the port number that our server will listen on. You can choose almost any number between 1024 and 65535, but 3000 is commonly used by devs. But what is a port? A port is essentially a communication endpoint. Think of your server as a large apartment building, and each port is an individual apartment. Just like an apartment has specific numbers, a port has a specific number too, which helps identify different types of traffic. When a request comes from the internet to your server, it needs to know exactly where to deliver that information. That's where ports come in. They help direct the traffic to the right place. For example, when we set the port number to 3000, we're telling our Node server to listen for requests coming into apartment number 3000. This system allows a single server to host multiple services simultaneously, just like a single building can house many families. Typically, different services will use different standard ports. For instance, web servers usually listen to port 80 for HTTP traffic and port 443 for HTTPS traffic. But for local development, we often use port numbers like 3000, 8080, or others in the range about 1024, as these are generally available and don't require special permissions. Finally, we want to tell our Express app to start listening for incoming connections on the port. When the server successfully starts, the callback function is executed, logging a message to the console. Alright, let's test this server by starting it up. For that, we go to our terminal and add node index.js. Press enter. And we see that it's giving us the console message we asked it to write out. Server running on localhost 3000. Perfect, so the server is actually already up and running. That's how easy it is to just get it up and hum away. It's not doing anything, but it's actually working. Okay, let's shut it down, and we use that by using the Control-C shortcut. Let's get the server to respond something whenever someone is reaching out to the server. Just above the port declaration, we can add this line. This line establishes a route handler using the app.get function, configuring the application to listen to the GET request on the specified path. Here the path is the route, indicated by the slash, meaning the handler listens for requests made to the route address. GET is one of several HTTP request methods, alongside others like POST, PATCH, and DELETE. When a GET request to the route is received, the provided callback function is executed. This function uses the response object to send the text "Hello World" back to the client. Here, rec and res represent the request and response object respectively. The .send method on the response object is used here to send a string to the client, though it's capable of sending various types of data. We will get into routes more deeply in a later video. Okay, let us save the file and restart the server to see if we can get the response. So we can go back to our terminal. To add the line we had previously, all we need to do is push the up key until we find the line we want, and press enter. And we see that it's now just sitting and waiting for something to call the route. So we can open the browser and just go to localhost 3000. And there we see our hello message. If we go to any other number, we will not see anything. So if we change this to 5000, we'll get an error message. But not on port 3000. We'll get our old good hello world message. Now, if I want to do any changes, let's say I want to send welcome to the world of connectivity instead of hello world. We need to shut down the server, change the message, restart the server, and then send another request to the server to get the updated message. Right now it might be okay, but when you do a lot of testing, it is just cumbersome. So let's fix that right away by installing another nice tool called Nodemon. We will install that by using another flag. So we use npm I Nodemon-d, and the -d stands for developer. So this will only be used during the development and not when it's shipped off for production. What Nodemon will help us with is that every time you save your file in a project, it will automatically restart your server. As I said, this is only to be used during development. Now that we have it installed, we can go into our Package.json file. As you can see, Nodemon has been added under dev dependencies, because it will only be used during development. In the scripts, we can now add 2 lines that will help us out a bit. First, a start script. Node index.js is a standard script for starting your application. We would use this in a production environments where we don't need Nodemon. Then we use dev Nodemon index.js. This is the script we will be using during development. It starts our server with Nodemon instead of plain Node, enabling the auto restart feature. Alright, let's save this and test it out. In the terminal, we add npm run dev. Now we have started the server in developer mode and can now just save files as we go and get the server restarted right away. And we can shut down whenever we want with the Control-C shortcut, and we get a yes or no question. Just press yes and enter and we shut down. Okay, let's restart it, and then we can go back to our index file and change the text to anything we want. Back with Nodemon, and just save it and send the request from our browser, and we get the new message. And Nodemon just saved us a little bit of work that will be a lot in the long run. Alright, now that we established our API is functioning correctly, able to receive requests and return responses, we can now move forward. Even if it seems basic at this stage, let's proceed by creating a small game client application in Unreal Engine. This will allow us to connect to our API and display the information configured within the API directly in our Unreal Engine game. Here we are in the Unreal Engine launcher, and we're going to create a blank 5.3 project based on C++. Target is desktop, and we don't need any starter content. I will just name it API testing and press create. Alright, here we are inside our newly created project. What I will start with is to create a new level, as I like the totally black empty levels when creating a widget only application. So let's create some folder structure. First a _game folder, then a maps folder, a util folder for our game mode blueprint, and a widgets folder. Okay, before we move on, we can save the map under the maps folder. I will name it main map. Under the project settings, I will change the startup map and the default map to our new main map. Let's also go into the editor preference and change two things. Under the asset editor open location, I want this to be main menu, and I also want to turn off live coding. Okay, now that we see that in a blank project like this, we don't have a C++ folder. So let's create that by adding our first C++ script. And we do this by going up to Tools and New C++ class. Under all classes, search for Game Mode Base. Click Next, and we can keep the name as is. And we create class. And this will open the EDI. Just hit the reload button. Alright, we can now see that we got the C++ classes folder in here. Let's create a blueprint from our game mode. This will be the blueprint that we will interact with from within our HUD widget. Name it GMBP for Game Mode Blueprint and place it in our util folder. Compile, save and close it down. We can now go into our project settings, and on the maps and modes we add our new game mode. And just make sure that the game mode override has our new game mode. Next, we can create the widget we're going to use to present the result of a HTTP call to the server. So under widgets, we can create a new user widget blueprint. Let us call it HUD and open it up. All we want here is a text field for our response and a button to make the request. So we start with an overlay and then a vertical box that we max out. Then we add two horizontal boxes and set them both to fill. Add a button to the lower horizontal box, set it to fill and center alignment. And then add a text field to the top horizontal box. This will be our response text. Set the text to fill and then center on the alignment. Change the font to 64 and change the outline settings. Size 2. Let's change the text to API response. Let's copy this text and paste it on top of the button as well. And just change it to send request. That is it for now, so let's compile this and save it. Back on the main map. We just want to add the HUD to the viewport. So let's open the level blueprint and let's go into the graph. After the begin play node, we get the Create Widget node and select the HUD widget. And then we add it to the viewport. We get our player controller and we set the show mouse cursor to true. Compile and save, and now we can just do a quick test and make sure that everything works. And it does, so perfect. This was a lot of groundwork, but we are now finally ready to do some C++ and make this happen. We're about to dive into some C++ coding. Don't worry if you're new to this, I'll guide you through each step. Instead of typing out everything in real time, I'll paste the code line by line. I'll avoid dumping large code blocks all at once. This way, we can focus on understanding each piece's purpose and function. We're here to learn, not just what to code, but why we're coding it. So let's proceed methodically, ensuring you grasp each part as we build this project together. First of all, we need to add the HTTP-module, and we do that in the build file. The build file is a C# script that defines the rules for compiling and linking individual modules to your project, among other things. It is located in the sources files and then in our project folder. It's named after our project, then build.cs. Okay, let's open this up. When we want to incorporate external functionalities like making an HTTP request, we need to explicitly tell our project that we intend to use these features. This is where the public dependency module names array in our build file comes into play. By adding the HTTP module to this list, we essentially informing Unreal Engine's build system that our project depends on the HTTP functionality provided by the engine. This ensures that all the necessary code and resources for handling HTTP requests are included and properly linked during the compilation of our project. Without this step, our attempts to communicate with an external web services like our Node API would be unsuccessful because the engine wouldn't recognize or support the required HTTP operations. So all we need to do is add HTTP to this array. Alright, done that, so now we can just save it and close it because that's all we need to do here. We're going to put all our HTTP code in our game mode file, just to make it easy for us. We'll start at the top of the header file by including the HTTP module, and we do that just above this generate.h file, as this has to be the last file included. We're going to need a constructor for this class, and a constructor is a special type of function in the class that is automatically called when an instance of that class is created. Its primary purpose is to initialize the object's properties with specific values. Essentially, it sets up the initial state of an object when it comes to life. First, we'll declare the constructor. We add this line within the class definition. This line signals the existence of the constructor specific to our game mode class. Next, we move to implementation in the CPP file to define what our constructor actually does. This is the syntax for defining the constructor's functionality. Currently, it's empty in closed braces, meaning no special actions are performed when an instance of the game mode is created. However, this is where we put any code we want to run when we're initializing the game mode. Returning to our header file, we want to have a private section. Then we want to add this line of code. This is where we declare a variable that is of the type FHttpModule. This class handles HTTP requests and responses. The asterisk indicates that HTTP is a pointer. Now, pointers is a very large subject in itself, and I urge you to look into how they work if you're unfamiliar with them. In our constructor, we initialize the HTTP variable by assigning it to the address of the HTTP module instance obtained from the get method on the FHttp module. This method returns a reference to the singleton instance of the HTTP module class, which manages HTTP operations. So what is a singleton? Well, it's a design pattern that ensures a class is the only one instance throughout the application's lifecycle. And why is that important? Well, this is particularly useful for managing resources and operations that inherently requires a single point of coordination, like logging, database connections, or as in this case, handling HTTP requests. By using the ampersand, we're converting this reference to a pointer. This pointer is then assigned to our HTTP variable, effectively linking our variable to the engine's HTTP functionality, ready for us to use in our project. Now to clarify, the word get here has nothing to do with the HTTP verb get. It is just the name of the method provided by Unreal Engine. This method is used to get or obtain the singleton reference. Now I want to create a new function. This will be sending the HTTP request to the server. In the header file, let's add a protected section. And here we can add a function that will handle the request. Let's create the definition. Alright, now at the top we can add this line. This will let us create the actual request. So what does all this mean? This line of code initiates the creation of an HTTP request that is both thread safe and automatically managed. It ensures that HTTP requests can safely be used in a multi-threaded environment, reducing the concern about memory leaks and data races. The tshared_ref part signifies that this is a shared reference, meaning that it's managed to ensure automatic memory handling, contributing to safer and cleaner code. We then assign this newly created request obtained from our HTTP object's create request method to the variable name request. This setup ensures that we have a robust, thread-safe HTTP request ready to be used. Before we send a request to the server, we need to establish some parameters for the specific request. First of all, we should define the callback to what we actually want to do when we get the response for our request. I think the code is pretty straightforward here. In this line, we're utilizing the onProcessRequestComplete complete method from the request object to bind our callback function. This ensures that once a request is processed and response is received, the specified actions within onGetResponse will be automatically executed. We have yet to create this callback, so that's our next task. Now, let us give the order. Where is the game supposed to find the server? So, we set the URL to the local host and the correct port. Next, we want to state what kind of request we're sending, and this one is just a regular GET request, so let's add that. Okay, that's pretty straightforward. Let's now proceed by adding two headers to our request. What are headers? Well, in short, headers are key value pairs sent between the client and the server, which provides essential information about the request, or the response. Think of them as the metadata of your HTTP request, offering instructions or information to the server or client without affecting the main content of the message. Alright, the first of the two headers is the user agent header. This can be utilized in an API to tailor responses based on who sent the request. Since we are developing both the client and the server side, we have the flexibility to decide whether we want to use this or not. The second header we will add is the content type. Although it's not currently necessary since our request is a GET operation without a body, including it makes sure that all our code are consistent. It's often considered good practice to maintain such standards, even when it's not immediately required. I could have left the headers out, but I wanted to include them here as they are vital to any project that goes beyond this point. Finally, we are ready to process the request, and in this line, we'll send it off to the server. Okay, that was the request, so let us now go and handle the response. Alright, the response callback looks like this. This function is designed to be a callback that gets called after an HTTP request has been completed. Let's break down the components of this function declaration. Alright, first we have the FHttpRequest request pointer named request. This is a pointer to the HTTP request object. It allows you to access details about the original request that was made, such as the URL, headers, and what HTTP method was used. Then we have the FHttpResponse response pointer called response. This is the pointer to the HTTP response object. If the request was successful, this object contains the server's response, including status codes, headers, and the body of the response. Finally, we have a bool called be connected successfully. This is a Boolean flag indicating whether the connection to the server was successful. A value of true means the request was sent and a response was received. False indicates there was a problem before the HTTP response could be received. Alright, let us create a definition of that and go to the CPP file and work a bit on it. So what do we want to do when the response comes back? Well, the first thing we want to know, was the request successful? So the first thing we do is adding an if-else statement with a bool we get from the response object. Right, before we start working on the successful part, let us handle the unsuccessful part first. So we want to log something into the console if we were unable to connect to the server. And we do that with a UE log and just a message, failed to connect to the server. Okay, but if we get a positive return, then we want to verify the validity of that response. This involves two key checks. Firstly, we need to ensure that the response itself is valid. This is achieved through the isValid method, which checks if the response object exists and is properly initialized. Secondly, we'll assess if the HTTP response status code indicates success. Status codes in the 200 range signify successful requests. We accomplish this by using this code block. This will evaluate whether the response code falls within the successful range, for example 200 to 299. In the description you'll find a link to an Excel sheet with all the response codes used in HTTP. So if the request passed these two tests, we know that the request is valid and have a positive response code, and we're good to continue with the code to handle whatever is in the response. However, before we do that, let us handle if something goes wrong and this check fails. For now, we can do another if-else code block here. If the response is valid but it returns an error code, we can do another UE log to the output that informs us that something went wrong with the request and showing us the status code. Then we have the last possibility that the response is just invalid. Then we can put that in the else section. This usually indicates that the request could not reach the server at all. For example, we forgot to turn on the API. Alright, having handled that, let us focus on the next step, utilizing our response. Currently, the response comes as a simple string of text. Since we're not dealing with any JSON data at the moment, our objective is straightforward. We'll assign this string to an fString variable. This variable will then be used to display the content within our widget. So what we can do is create an fString variable that can be accessed from the blueprint. So in the private section of the header file, we can use the following declaration. So this is a regular fString that we can access but not change in blueprints. And the meta allow private access allows this to be shown outside of this class even though it's in the private section, helping us with encapsulation. Okay, in the CPP file, I would like to initialize this with a basic value of nothing yet. So we know that we have not sent an HTTP request. So we can create a initializing list on the constructor. Alright, in our response, if the response is valid and the response codes are okay, then we want to fill this variable with the response text. Now we have a response in the response body. Well, almost, right? Well, we haven't actually sent the request yet, so let's do that now. In the header file, we want to create a function that will be triggered when we push the button. So we can add a public section at the bottom, and then we add the function. Now, this function is blueprint callable. So that means we can access it from within the widget. Let's create a body for this function. All we really want to do here is to call our send HTTP get function. Alright, let us now build this and go back and just hook it up. Alright, back in Unreal, we can open our HUD widget. First, we need to make sure that our text item and our button are variables. Then we can go to the graph. On the button, we want the onClick function. we need to get our game mode. And we're going to cast it to GMBP. That's the blueprint we created. And then we're going to get our myHttp request function that we created in C++ and made blueprint callable. Alright, moving back to the designer, we need to create a binding of the text for the API response. So in here we can start by getting the game mode. And again, we want to cast this to GMBP. Let us promote the game mode to a local variable. And drag the variable out. And let's check if it's valid. If it is not, then we drag it to the cast. Now we want the response body variable from the game mode. And before we hook this up, we want to promote the return value first. Now we can set the return value with the response body text. And of course, we want to do that from the isValid as well. Okay, let's compile and save this. That should be all we need to do. Let's make sure that the server is up and running. So all we need to do now is to test the button. Before we end, I would like to change the text in the API so we can see that whatever is returned from our API is current and live. And there you have it. We covered a lot of ground today in our journey through the basics of Node.js. We started from scratch, setting up our very first Node project and integrated Express to understand the power and simplicity of web frameworks. Throughout our hands-on approach, we created our inaugural API, mastering the essentials and witnessing firsthand how a few lines of code can open a channel for client-server communication. We didn't stop there. We dove into a dynamic world of game development with Unreal Engine, where we designed a HUD and a widget system, complete with a functional button. By pressing this button, we initiated a request to our freshly minted API, capturing and displaying the response right within our game environment. The seamless integration between Unreal Engine and Node.js exemplifies the incredible potential of combining game development with web technologies. To streamline our development process, we incorporated Nodemon, automating the server restart on every save, which significantly sped up our testing and debugging cycle. No more manual restarts, every change was instant live, propelling us into a more efficient development flow. Throughout this tutorial, we navigated through the creation of a basic but fully functional communication bridge between Unreal Engine, C++ project, and a Node.js server. We learned to send an HTTP request, handle responses, and reflect changes in real time within a game environment. This is just the beginning of what is possible when you merge the realms of game development and web technology. I hope this tutorial has illuminated the path for your continued exploration and innovation. The skills you acquire today are the building blocks for more complex and exciting projects ahead. Keep experimenting, keep learning, and most importantly, keep creating. Thank you for joining me on this adventure. Here is to your success in all your future coding and game development endeavors. Until next time, happy coding.